Tech AV welcomes you to the second program in this series, in which you are going to learn the procedures and principles for performing routine maintenance for conventional three-phase squirrel cage induction motors. As you know, any equipment, be it mechanical or electrical, requires periodic attention to ensure an economic service life. Squirrel cage motors require very little maintenance, which is one of the reasons for their popularity. However, the little maintenance that they do require is very important, so let's overview the main points. In this program, we are concerned with three aspects, namely cleaning, lubricating, and mechanical checks. The cleaning of a motor may seem insignificant, but as you'll soon learn, it is of great importance. In many operations, motors have to work in very dirty surroundings and naturally become covered in deposits of dust, grime, chemicals, or other airborne impurities. The only way that a motor can maintain a safe operating temperature is through airflow across the air fins. This airflow is aided by the cooling fan. The transfer of heat generated within the stator takes place by conduction into the metal fins. The airflow over the motor removes this heat to the atmosphere. Should the transfer of heat be impeded due to the blanketing effect of a layer of dust or dirt, then the motor will run hot. When a motor runs hot, damage to the stator windings and rotor shaft bearings occurs. For obvious safety reasons, we suggest that motors be cleaned only when the plant is stationary and isolated. Simply by keeping a motor clean and dust-free, we can dramatically increase the effective working life and reduce repair bills. A dry rag or paintbrush is often all that is needed to get rid of dirt and dust. The shop air line may also be used, providing you take the necessary safety precautions for working with compressed air. Where a motor is dirty, from oil or encrusted matter, then it should be wiped using a rag moistened with an electrically safe solvent or degreaser. Never use flammable liquids such as petrol to clean electrical apparatus whilst on the plant. Moving on now to lubrication. The only components needing periodic lubrication are the bearings, and then only when necessary. Most smaller type motors do not have grease points and therefore require no greasing during their working life. Motors that do have greasing points require greasing only at the specified intervals. Modern motors have a grease bleeder incorporated into their grease housing, whereby you can see old grease being evacuated as you pump new grease. It is important, however, to ensure that grease bleeders have not become clogged, which would result in over-greasing the bearing. Where bleeder plugs are employed, they must be reinstalled after greasing has been completed to prevent clogging. It is extremely important that bearings are not over-greased. This results in rapid overheating and subsequent bearing failure. As a guide, motors usually receive grease after between 500 and 4,000 hours of running. Records of running times and service schedules should be kept and maintained by the plant engineers. Motors that do not have grease points are only lubricated when the motor is dismantled during regular inspection services. At such times, the bearings are fully cleaned, inspected, and if reusable, repacked with the necessary amount and type of grease. A properly lubricated bearing is 2/3 packed with grease. Note that the rolling element separators are visible, leaving room for expansion as the bearing temperature rises. Stop the tape now for discussion or reference to your workbook.